Okay, in this presentation we're going to look at exponential families of random variables. So the question is, define what it means for a random variable to belong to an exponential family, and the second part is, show that if a random variable has an exponential distribution, show that it belongs to an exponential family using our definition. Should be straightforward enough, but it's just to sort of map things out properly. So part A, a random variable y belongs to an exponential family if the probability density function of y can be written in the following form. So here we have f of y, and there's two other parameters here, theta and phi, okay? And the basic idea is that we want to be able to express the probability density function in the following format. The exponential of this expression here, so we have two parts to it here. So y times theta minus b of theta divided by a of phi. And the second part is minus c of y and phi, where a, b, and c are functions. Okay, so y theta is a product of the y and theta, b is a function of theta, a is a function of phi, and c is a function of y and phi. Okay. So that's the definition, okay? Now I have it here again, and what we're going to do is apply this to part B. Suppose that the parameter of the exponential distribution y is lambda. So essentially what we're saying here is, this is just the pared down form of it here. This is the key part of it here. Actually, incorrectly, the probability density function is more complicated than that, but this is the core component of it. F of y equals lambda times the exponential of minus lambda times y. So what we're going to do is split that up into two parts. So we have lambda there. So I'm going to re-express that as the exponential of log times lambda. And the other part there, the exponential of minus lambda times y. Okay. Now, essentially what we can do is add them together. So, or multiply them out, which means adding the components together, this part here and this part here. So what we have is the exponential of log lambda minus lambda times y. And what we could do is re-express that as lambda times y minus log lambda divided by minus 1. So it's the exponential of that, okay? So that's what we have in the form that we need. So theta here is lambda, okay? A of phi is minus 1. B of theta is log theta, okay, or log lambda. Okay, here lambda equals theta for the purposes of what we're doing. And C y of phi equals 0. Just alternatively, you can construct it as in the following format here, using B of theta equals minus log of minus theta. Okay, which is same thing. Okay, so we'll leave it there.